Hi guys, it's Mr. Habrick, and here's the notes for lesson 8.6. We're kind of taking a shift now, and we're going to talk about what happens when you have um, rational exponents. But before we get to that, we have to talk about what rational exponents really are. What rational exponents are refer to roots. And the first thing that chapter or section 8.6 talks about is the concept of roots other than square roots. You guys are probably all familiar with your perfect squares and the roots for those squares. But you can find roots of just about any number, like cube roots would look like this. Cube root of 27 is 3 because 3 cubed equals 27. This little number up here inside the radical, and you can see it here, it's the n that we have here. It's called an index. And the index tells you what type of root we're looking for. So like in this example here, we are looking for the fourth root of what's inside the radicand. But in order to solve these kinds of problems, we have to use our properties of roots. And they're kind of similar to the properties of exponents. The product property says that the nth root of AB is like the nth root of A times the nth root of B. We could do that to break down square roots and simplify them. You can do the same thing with radicals. And for example here, what if I had something like this? Let's go over here. The cube root of 16. 16 is not a perfect cube, but I could have the cube root of 8 times 2. 8 times 2 is 16, and 8 is a perfect cube. It's 2. So to simplify this, I get 2 times the cube root of 2. Now the same thing works when you've got variables, and it's actually a little bit easier when you have variables, and we'll get to why in a moment. But if you look here, we have the fourth root of 81, x to the 8th. Well, you see what they did here. They've got, well, I'll just use my highlighter. They've got 81 is 3 to the 4th, and they broke down 8, x to the 8th, into x to the 4th times x to the 4th. So these 4's, the 4 exponent and the 4 index, are going to basically cancel each other out. That's the whole concept of a root. So we get 3 times x, or 3x squared. We'll get to another way of looking at that in a moment. But if we look down here, well, yeah, nth root of a to the nth is just a because they cancel out. We also have the quotient property. If you remember the quotient property for square roots, if I had like the square root of 25 divided by the square root of 16, that would be like the square root of 25 divided by the square root of 16, which would become 5 over 4. So the way this works for radicals is if I have the nth root of AB, it's basically going to be the nth root of A divided by the nth root of B. So you can break these guys up. If I have the cube root of x to the 9th divided by 2, I get the cube root of x to the 9th divided by the cube root of 2. Well, notice here that they got the cube root of x to the 9th is x to the 3rd because they broke it down. But I'm going to show you, I'll just show you right now, why not? There's an easier way to think about this. 9 divided by 3 is 3. This is your numerator, that's your denominator of a fraction, and you can simplify it that way. Now, where it gets complicated is we don't want a radical in our denominator, like this guy here. And that's my poor attempt at drawing an arrow. There you go. So we're going to have to figure it out. Cube root of 2, they're going to multiply it by 2 more 2's. So I get a 2 cubed, and it'll cancel out, which means up top I got 2 squared. So I get this, cube root, or x to the third, cube root of 4 divided by 2. Yeah, it's not fun, but you can do this. Let's take a look at number 1 here. If I have cube root of x to the 8th times the cube root of x to the 4th, I'm going to combine them under a single root. That's going to be the cube root of x to the 12th. Remember, we add our exponents together. So if you remember what I just showed you, what's 12 divided by 3? That is 4. So this is going to become x to the 4th power. It's a lot simpler than trying to break it down. Just think about this as that's your numerator, that's your denominator. Divide, you're going to get 4. If we look at number 2, 4th root of x to the 8 over 6, that's going to be 4th root of x to the 8th over the 4th root of 6. Well, let's see. 8 divided by 4 means I got x to the 2nd on the top, and I got the 4th root of 6 in the bottom. So this is what I'm going to have to do. I'm going to have to multiply the top and the bottom by some value that is going to make this 6 to the 4th. Well, if I have 1 6, I'm going to have to multiply the top and the bottom by 3 more. So 4th root of 6 cubed. Multiply it out. What happens up top? I get x squared times the 4th root of 216 divided by 6. That is the answer. Don't worry about, with practice, this is going to come to you, don't worry. If we look at number 3, I'm going to break it down. Cube root of 125 times the cube root of x to the 6th. Cube root of 125 is 5. And you can evaluate that on the calculator, or you could remember some of your perfect cubes. Cube root of x to the 6th, 6 divided by 3 is 2, so this is going to be x squared. Problem like this one here. I'm going to have the 5th root of 64 divided by the 5th root of 2x to the 10th. And this is going to get a little complicated. 64 is, I believe, 2 to the 5th. Actually, you know what? Scratch that. We're going to do this a little slightly bit different. 64 and 2, I'm going to make this the cube root of 32 over x to the 10th. 64 divided by 2 is 32. Well, guess what? Cube root of 32 divided by the 5th root of 32 divided by the 5th root of x to the 10th. That's going to be 2 over x squared. Because the 5th root of 32 is 2, 10 divided by 5 is 2. So we get 2 over x squared. Alright, number 3. Make it a single radical. Multiply these guys together. 2 times 4 is 8. X times x squared is x cubed. You can combine them under a single radical because they're both cube roots. Cube root of 8 is 2, and the cube root of x cubed, if they're the exact same, the root and the exponent cancel out, leaves us with 2x. 4th root of 625. Yeah, I'll break it down. After you've done enough of these, you really don't even have to do this step, but I'll do this step because why not? 625 is 5 to the 4th, so this is going to be 5. 4th root of x to the 8th, 8 divided by 4 is 2, so this will be x to the 2nd. Alright, so what I'm getting at here with these dividing the indexes and dividing the exponents is this. The nth root of a number can be used using a rational or a fractional exponent. This right here. The nth root of a is like a to the 1 over n power. So if I have 121 to the 1/2, what I really have is the square root of 21. We don't write an index of 2 with squares, but it is 2, and that's 11. If I have the 216 to the 1/3, that's the cube root of 216, which is 6. 256 to the 1/4, fourth root of 256, it's 4. So now, what this leads to is this concept of a rational exponent, where you have a to the m over n is the nth root of a to the m power. And it actually will also equal this. It'll also equal the nth root of a to the m. You can have that exponent inside or outside, it really doesn't matter. So when I have a fractional exponent, like so, I can actually evaluate these on my calculator if I want to, but I don't have to. 64 to the 2/3 power is going to be the cube root of 64 squared. That's the cube root of 64 is 4. 4 squared is 16. Negative 32 to the 4/5 power is the fifth root of negative 32 to the 4th. You can have a negative if your index is odd. So this becomes negative 2. The fifth root of negative 32 is negative 2. Negative 2 to the 4th is positive 16. So these can be written either way. You can go back and forth. Square root of 5 is like 5 to the 1/2. Fourth root of 6 cubed is like 6 to the 3/4. Let's simplify some of these. 27 to the 4/3. Well, that's going to be the cube root of 27 to the 4th. The denominator is your index, and the numerator is your exponent. Exponent, index. Cube root of 27 is 3, so I get 3 to the 4th, which is 81. 49 to the 3/2. All right, well, let's make that the square root of 49 cubed. So that would become 7 cubed, which is 343. 16 to the 3/4. Make it the fourth root of 16 cubed. Fourth root of 16 is 2. 2 cubed is 8. If I want to rewrite these as rationals, just like I said, you've got the exponent in the numerator and the index is your denominator, so I have 4 to the 2/5 power. Square root of 19. 19 to the 1/2 power. Remember that if you don't have an index, we assume it to be 2. If you don't have an exponent, we assume it's 1. Fourth root of 6 to the 5th. 6 to the 5/4 power. Alright, so how do we simplify these? Well, it can get a little complicated, but it's not really impossible. Let me show you. What I'm going to do with this guy here, 24 divided by 3, I'm going to simplify inside first. That's going to be 8 over x cubed. I'm going to make that to the 1/3. So what I end up with is 8 to the 1/3 over x cubed to the 1/3. Well, 3 and 1/3, they cancel out. So I just get x in the bottom. Up top, 8 to the 1/3, remember, is like the cube root of 8, which is 2. So I get 2 over x. Square root of 49 times the cube root of 8x to the 6th. All right, well, square root of 49, that's easy. 7. Cube root of 8, that's 2. X to the 6th, cube root of x to the 6th. Well, that is like x to the 6/3. Just like I was showing you on the previous page, that is going to be x squared. So now it's just some simple multiplying. We get 14x squared. Square root of 117/13. Alright, my guess is that 117 is actually a power of 13, or a factor of 13. Let's see, 117 divided by 13 is 9. So I'm going to get the square root of 9. That is, well, 3. There it is. Yeah. All the power properties work with fractional or rational exponents as well. So, like, let's scroll down so I can remind you of what they are. So, like, if I had, remember, a to the m times a to the n is a to the m plus n. So, a rational example, if I had like 2 to the 1/2 times, or 12 to the 1/2 times 12 to the 3/2 would be the same as 12 to the 1/2 plus 3/2, which is 12 to the second power, or 144. Remember that also, quotient property. A to the m divided by a to the n is a to the m minus n. So let's say I had 125 to the 2/3 divided by 125 to the 1/3. That would be 125 to the 2/3 minus 1/3. 125 to the 1/3 power, which is 5. Excuse me. Power of a power. If I have a to the m to the n, it is a to the m times n. So that would be like, let's say I had 8 to the 2/3 cubed. Give an example kind of similar to this. This would be 8 to the 2/3 times 3. 2/3 times 3 is 2. So I just have 8 squared, which is 64. And then we have the power of a product and the power of a quotient. If I had AB to the m, it's like a to the m, b to the m. So a product can be raised to a power by breaking it up. So if I had like 16 times 25 to the 1/2, that's going to be like 16 to the 1/2 times 25 to the 1/2. That would be 4 times 5, which is 20. And then finally, a quotient, power of a quotient, it's going to be a to the m divided by b to the m. So fractional example, let's say I had 16/81 to the 1/4. It'd be like 16 to the 1/4 divided by 81 to the 1/4. That would be 2 divided by 3 when I work it all out. So all these power properties work with rational exponents just like they did with regular full-sized exponents. So there's 8.6. Your assignment should be posted in Schoology. Let me know if you have any questions. Don't forget to smash that like button if you learned something today, and subscribe. And you'll be able to see math lessons like this, like every time I record one, which is at least a couple times a week. All right. Good luck.